Alright, here's 10.3. We're just going to call today day 1 and get through some of the basics here of double angle formulas. Same idea with sum and difference, is we want to take up kind of the repertoire of angles that we could find exact values for and increase them. That was the name of the game with the sum and difference formulas, and that's the name of the game here. All right, I want to take a look at a couple different kinds of problems today that we could try to take care of with these double angle formulas. All right. So the first formula that I have for the sine of 2 alpha, and what I'm given to start this problem, states that sine of alpha is 4/5, and alpha is between 0 and 2 pi in radians, which is just one way of saying that it's in quadrant number 1. Okay, my double angle formula, which is on our sheet, labeled in the section double angle formulas, states that sine of 2 alpha is equal to 2 times the sine of alpha times cosine of alpha. Well, as I'm calculating this, things are just going along fine. Okay, until I see that I need to know the cosine value for alpha, which I don't, but I can figure it out. If I just do a quick little sketch here, I'm talking about an angle. It's in quadrant 1. Remember, sine and cosine values always come back to x, y, and r. Sine is y over r, which means I have those two. It would follow from the Pythagorean theorem that x has to be 3, and I get a very valuable piece of information that cosine of alpha is 3/5. Now I'm going to look ahead here a little bit and think about tangent. Tangent is y over x. Well, that's 4/3. Okay, that's good to have as well. That may come up later. I can proceed and simplify as soon as all of my trig functions are gone. And at this point, they're gone. Okay, sine of alpha is 4/5. Cosine of alpha is 3/5. Multiplying straight across the top, I get 24. Straight across the bottom, 5 times 5 is 25. Done. Okay, there's the sine of 2 alpha. Exact value. Cosine of alpha is really not a lot different. We have 3 different forms here that we can pick from. In this problem, it really doesn't matter a whole lot. You got 1 minus 2 sine squared of alpha. That's the one I'll go with. Okay. 1 minus 2. We were given that sine of alpha is 4/5, so I'll take that squared. Okay. I'll take that squared. This would be 1 minus 2 times 16 over 25. That would be 32 over 32. Whoops, I don't want 32 over 32. That would involve getting a common numerator. That doesn't do me any good. When I multiply this term by 2, I get 32 over 25. Rather, it's going to be quite helpful to get a common denominator of 25. Which leads to negative 7 over 25. There's the cosine value of 2 alpha. It says to find tangent. I'm running out of room here, so I'll get you set up on this one, and then you can take it from there. Tangent of 2 alpha. Well, that equals, according to our formula sheet here, not according to the sheet, it's been proven. We have not gone through the proof ourselves, so we're just buying what our book is selling. I feel pretty confident in that. 2 tangent of alpha over 1 minus tangent squared of alpha. This is just based on the tangent value, which I figured out was 4/3. So I will leave it to you to simplify 2 times 4/3 divided by 1 minus 4/3 squared. That needs to be simplified. Okay. We can simplify some expressions if we can identify the correct formula that's being used. Okay. Best thing to do is just fill it in with a variable and see what it gets you. Okay, let's say 10 degrees is alpha. We have anything in our sheet that looks like 2 sine alpha times cosine alpha? And we certainly do. That's the double angle formula for sine. So I could say that equals sine of 2 times 10 degrees, which would be the sine of 20 degrees. Okay. Really nothing we could do there in terms of simplifying it further. We could go to the calculator to get a decimal approximation. But as far as having an exact answer, that's where we'd have to call it quits. Look at this one. We could take cosine squared of alpha minus sine squared of alpha. That's a double angle formula for cosine, assuming that alpha is 15 degrees. Now here we find ourselves in a little bit different story, because cosine of 30 degrees, we can simplify that with the unit circle. Square root 3 over 2. This definitely looks like the double angle formula for tangent with alpha equal to 50. Okay, sine and cosine are a little bit more work, but tangent is the only one that involves tangent, so it's quite a bit easier to distinguish. 2 times 50 is 100, similar to the first one. There's really nowhere to take that as far as an exact answer. We just leave it as tangent of 100. Okay, so that's all you're going to see in the first day's homework. Double angle formulas, just simplifying basic expressions using those formulas.